Here we're going to evaluate yet another integral between quarter and a half, 1 over x cubed dx. And first step then is to make the 1 over the x cubed into a power function. We're going to rewrite that as x to the minus 3. That's our first step. So x to the minus 3, we can now produce the antiderivative of that. The antiderivative increases power by 1, x to the minus 2, divide by the new power, minus 2. So we're going to write that on the other side, over here. One little square brackets, quarter, half, and then we're going to write the new function, the antiderivative, which looks like that. X to the minus 2, we've increased that by 1, divide by the new power, and then we can rewrite that so that it looks slightly more usable to human eyes, I suppose. So that's going to be minus 1 divided by 2x squared. Okay, the minus 1, 2 on the bottom, and x to the minus 2 is 1 over x squared. And then we go through that process of giving each one of these limits its own box. We're going to subtract from that the lower limit, so the upper limit here, the lower limit one there, and we feed in the value of the upper limit into the function. So we have minus 1 divided by 2 times x squared, that gives a quarter, 2 times a quarter, okay, so 2 times a quarter, we'll finish that off in a minute. This one over here, minus 1 divided by 2 times a quarter squared, which is a 16th. And we just process that one till we get to the end. 2 times a quarter is a half, so that's minus 1 divided by a half, which is going to give us minus 2, minus 2 times a 16th is an 8th, so you're dividing by an 8th, so that's going to give us minus 8. Minus 2 minus minus 8 is going to give us plus 6. And once again, I'm going to show you through Desmos that particular integral calculated out. Thank you very much. So here we are with Desmos again, and I'm just going to draw the function 1 over x cubed. And in this case, I've put a domain on the function which matches the one that we're solving in the example. So our first step then is to find out what the antiderivative is. And here you can see the antiderivative is drawn in blue, and it has a positive slope. So that suggests that the area under the curve is going to be positive. Let's take a look at that. Okay, so now I'm going to show you the area under the curve, and you can see it's that grey shaded area there. When you add up all of that shaded area, you can see that the system tells us that the answer is equal to 6, which is the answer we got working through the example ourselves. And once again, the difference between this number here at the top of the antiderivative, which is minus 2 up there, and down here, the solution is, if I just get the very end of that, minus 8. The difference between minus 8 and minus 2 is 6. So there you go. That's another example of the antiderivative showing you that it's equal to the area under the curve between some specific limits.